Next up we have Chris Horsley from Cosive. His presentation is titled Maturing Your Security Team, Haste Makes Waste. Please welcome to the stage Chris Horsley.
Good morning, everyone. My name's Chris Horsley from Cosive. The topic I'm going to talk about today, it's a bit of a reactionary talk of sorts. When we come to conferences like this, there's a real bias, I think, towards, we're talking about the most novel types of techniques about how we can do incident response and how we can detect new incidents that are coming in. Part of my job is going out to incident response teams and consulting with them and seeing how they're doing things today. And what I see a lot is that there are some fundamental issues in the way people are doing incident response, and they've got to follow a certain roadmap before they're at the point of doing all the fancy new things that we're talking about at these conferences. So today I'm going to talk a little bit about a few of those fancy techniques that I think are talked about a lot and that are useful, and then present a roadmap about how you get from where your CSERT is today, where your incident response team is today, to being able to use these interesting techniques. So a quick introduction to myself. It's always good to know the biases of the speaker, I think. I actually started at AusCERT about going over a decade ago now. I got a chance to work in Japan for JP-CERT, the national CSERT there. I moved back from Japan about 5 years ago and started a consultancy, building tools and consulting with CSERTs. And the last year I've joined forces with some other guys in the Australian InfoSec community, Kane Norton and Terry McDonald, and so we've now formed Cosive, so we're sort of pooling resources and experience. So what I'm going to talk about now, I've picked a few interesting technologies, at least to my mind, that are going to be very beneficial to incident response teams. It's not going to be too much of a deep dive into those technologies because we have plenty of presentations out there already talking about them. But I'm just going to fill in a few gaps maybe for people who haven't sat in on some of those presentations. And then we're going to talk about the roadmap and a maturity model for building an incident response team. So a quick point of definition. You're going to hear me use the word CSERT a lot in this presentation. I guess that's the background I've come from. Varyingly, they're called incident response teams, IRTs, CERTs. And then there's one other big gap. As you can see here, a lot of organizations will have a SOC, which is the monitoring and detection side, and they'll have a CSERT, which is the incident response side. Once they've detected the incident, this is how they're going to be containing and recovering from that incident and back to a good state. For the sake of simplicity, I'm just going to call this a CSERT or an incident response team. For a lot of organizations, they do the monitoring inside their incident response team as well. So when I use the word incident response team or CSERT, if your organization has a SOC, you can just mentally fill that in. So the first point I wanted to make was that it's the requirement to have an incident response capability. It doesn't matter how many magic boxes we put onto our networks to detect incoming attacks. We know already that we can't possibly know the known unknowns. We know that there are going to be successful attacks. We know that there are zero-day vulnerabilities. We know that at some point our networks are going to get penetrated. As the old saying goes, defenders need to be perfect all the time, and attackers just have to be right the once. So we have to expect that at some point that there is going to be a successful attack on our network, which means that at that point we're going to have to be able to respond to that incident. So deploying all of these fancy monitoring systems and analytic techniques are kind of moot unless we have a way to respond to the incident in an orderly manner once we have detected them. Oh, hello. Oh, I'm very sorry. This looks like... Sorry, technical glitch. Excuse me for 1 second. Is it Muzak? Thank you very much. I'll talk a little bit in the background while I load up this new slide deck. So the 4 types of technologies I'm going to talk about that I think are very much emerging in this area. This is the one I wanted. So the four I'm going to talk about are threat intelligence. I'm also going to talk about threat intelligence, hunting, big data, and machine learning. Sorry, just loading it up now. So naturally, we're hearing a lot about all these technologies. I would say in the last 2 years in particular. Maximize that. All right, we're back again. Okay, this is where we need to be. All right, so the first of these techniques I wanted to talk about was hunting. So hunting has become this new moniker that's kind of emerged in the last couple of years, but it's something we've really been doing for a long time. And it's the idea, there's a great blog post that I've linked at the bottom of this slide that I recommend anyone who wants to learn more about hunting, go and read. But as they define it, the collective name for any manual or machine-assisted techniques used to detect security incidents. So this is really something people have been doing for a very long time, but now we kind of have this, this brand to hang it all under, and you'll see a lot of presentations now about hunting and hunting techniques. This blog post is also great because it talks about the idea of a hunting maturity model. And it goes from, without walking you all the way through it, it goes from the bottom, when we're really just focusing on what our SIEMs tell us and what our alerts tell us, basically picking up attacks that we already know about, and then we work through these stages all the way over to the right when we're coming up with really novel techniques for looking at, for doing statistical analysis, for doing machine learning analysis, to look for attacks that were previously unknown and didn't have clear signatures. But like I said, that blog post talks very well about hunting, but I think this is something that all incident response teams and SOCs need to focus on. The next big thing that's emerged in the last few years is threat intel. Now, threat intel has become, in some ways, it's a very abstract term to a lot of people. You hear it get used in lots of different contexts. So I'm going to define the way we use it, at least. And it's the idea of understanding who is interested in you as an organization, how do they operate, and perhaps who are they? The answering the who are they is quite a difficult one. But the difference really between threat intel and what we often think about as threat intel being bad IP addresses, bad domain names, are that things like IP addresses and domain names are historical information. So if we know about them today, they're not going to be able to stop the attacks of tomorrow. But understanding the way that threat actors work, that's going to help us make much more or much better generic observations and generic rules to be able to detect future attempts from that same group. So we often talk about things like campaigns and threat actors and the like. So we use these terms here. So we have threat data. This is very raw data, things like IP addresses and host names that are drawn directly, say, from a log file. They're unvetted, they're unverified, they don't have a lot of context to them. So tipping them straight into an IDS or into a blacklist is quite hazardous because we don't have much confidence in what that data means. The next step after that is threat information. This is when we've got a measure of confidence in what we've received, and we've vetted it to some extent. So these are also quite, these are still fundamental. While I'm talking about threat intel here as being this understanding how threat actors operate and what are the tools they use, where do they hang out, what are they discussing as their next targets, that stuff's all great, but we still need this fundamental data and information to be able to still, set up our IDSs, set up our monitoring in a way that can see what's coming in. So very much I think when we're talking about the maturity of our CSERT and when we're ready for threat intel is actually it's very labor intensive, because if you can imagine, we're researching these groups and it often requires a lot of expertise and a lot of time to be able to piece together all of these different campaigns, say phishing campaigns, malware campaigns going on, and to draw the threads between them and to work out what are the linkages between these pieces of malware I'm seeing, or what are the linkages between these phishing campaigns. So it needs a lot of effort, manual effort if you're doing it internally or getting experts to help you out with that. And it also needs a lot of good data and a lot of good automation. And when we talk about CSERT maturity very shortly and that roadmap, I'll talk a lot about how we're going to achieve that. So threat intelligence fits in very well with incident response cycle. So there's an incident response cycle and a threat intelligence cycle, and my colleague Terry McDonald has come up with this symbiotic relationship between the two of them. So yesterday was a good talk, I believe, about the incident response cycle and the 6 stages of that. So where threat intelligence fits into that, at the top here you can see the indicators coming into our incident response process. So either from internal or external threat intelligence processes, we're seeing indicators come in. We're seeing ways of identifying badness coming into our networks, whether those are file signatures or some sort of aspect of a URL or something inside a web page, but things that we are known bad that we can use to monitor and detect new incidents. The bit that gets often neglected is the arrow at the bottom, because the most neglected bit of incident response is the post-incident review. Once we've handled the incident, it's about taking what we've learned from that incident, identifying the bad things that we saw, but not just dropping it on the floor and moving to the next incident, but then processing all that information, turning it into a parcel of intelligence, and then feeding it back into this threat intelligence process so that we can then use all those indicators the next time we're handling an incident. The other big topic, the final topic I'll touch on, are these two kind of in combination, big data and machine learning. So the aspiration for a lot of these technologies is that we can just collate all the information that we're seeing, and instead of having human analysts trying to draw correlations and make rules about badness and what we should be protecting in the future, it's about having algorithms that can do far subtler rules than we can possibly do as human analysts. And it's in an early stage at the moment, and there's a lot of promises, I think, made about machine learning today and what it can accomplish and how accurate it is. But unless you have the resources internally to, people who have real machine learning expertise, it can also go wrong. And in fact, my colleague Kane Norton is going to talk about that tomorrow morning in a keynote. So I won't steal his thunder. He will explain a lot more about this particular topic. So before we talk, these 4 topics that I've picked on here are things that we're talking about a lot of late. So it seems like we should all be doing them right now. But before that, we really have to go back and look at the fundamentals of incident response itself. So we already touched on this topic, which I'll move through. So we get on to the maturity model for a CSERT. So what I'm going to do here is walk through some of the steps from going from an absolute a lack of capability with incident response all the way up to an advanced team that is ready to talk about threat intelligence and hunting and machine learning and the like. So I'm going to illustrate this at points with this hypothetical CSERT. I'm calling them AusCERT. They work for ACO. It's a company of about 500 people. They have about 20 people in the IT department, so they're a medium-sized business. And it's a very typical business that we find out there. At this point, they have 2 system administrators, and nominally they are responsible for incident response. But when we start our story, they have no official mandate. They're not really thinking about it too much. So over the course of this, we're going to look at 5 different levels of maturity, and we're going to talk about how you progress from one to the other. So when we start at level -1, and we give it a -1 because it's nothing that we can call an incident response capability, because they're basically hoping that an incident doesn't happen. And since you're all here at a security conference, I'm really hoping that there's nobody here who is in this boat at the moment, if you've gone and seen a lot of talks here, but there are plenty of organizations out there that are certainly in this case, and they're organizations of 500 employees that have never really thought about how they're going to respond to an incident when it does happen. And in some cases, it may not be your organization, but it may be a partner that you do business with. And they might have an incident response capability. They might be holding onto your data. They might have a critical process that you rely on, but they have no idea about how they're going to work their way out of a critical incident that stops their business dead. So at this point, are they ready for threat intel and its cousins? They're really not. They don't even have incident response at this point. So that moves us on to level 0, an ad hoc team. It's a group of people who are very passionate about security, but at this point, they only come out at certain times, and they've got some cohesion, but they're not a serious outfit. So they're making do with what they have. So we've got our 2 part-time system administrators, and at this point, incident response remains a part-time responsibility for them. They're giving no budget to do incident response. They're given no official time or mandate to do incident response for the organization. But at this point, at least they're thinking a lot about incident response. And while they're doing the day-to-day sysadmin work, they're also thinking, what would happen if this system got penetrated, or what would happen if this system went offline? Yeah, we really need to do something about that. And while you're not set up very well for incident response, at least the thought process has started, and this stage 0 is a necessary step to get to the next point. But at stage 0, if we had an incident, we're going to be panicking because we haven't thought in enough detail yet about who's going to respond to incidents, how are we going to respond to incidents. Because when things are going wrong and managers are coming into an operational room, panic sets in. And when people are panicked, they fatigue faster. And when people are fatigued, they start making poor decisions. So this is why we say that incident response planning is essential. And in later stages, we're going to talk about how to do that. So are you ready for threat intel, machine learning at this stage? You're still a long way off it because we don't nearly have the visibility and the planning to be able to get any even if we had the data available, we have no plan for how to recover after we've determined that an incident is in fact happening. So that takes us to level 1. Level 1 is significant because it's when we're starting to build the capabilities of an actual incident response team, and we might even call it an incident response team at this point. So the first thing we've often done at this level is to define the team itself. The team actually knows who they are. At level 0, that wasn't even apparent. Who was going to be thinking about and responsible for incident response. So we formally defined that, yes, there is a CSERT. And in some organizations, that's going to be a virtual CSERT. So it's not going to be a group that's segregated off with a whole bunch of SOC style, a wall full of monitors. It could be people that are earmarked across the technology section or people from across the organization. They could come from risk, or they could even come from the legal department. And when an incident is raised, they come together and they're going to coordinate. And a virtual CSERT is often a stepping stone to maybe having a more dedicated capability. At this point, we've defined also some guidelines on the ethics and legality of how to do incident response. We need those guidelines because do we have, say, the ability, if we found a username and a password in some malware, and we know that our corporate information has been exfiltrated by that malware and it's sitting on a server, and all we'd have to do is type in the username and the password and we could get that back. In some jurisdictions, that is illegal. Even if they've stolen our data, we are still accessing a computer system in an unauthorized manner. So we have to decide, and I'm not a lawyer at all, and I'm not going to tell you if that's illegal for your organization, but it's something you do have to consider. And that's going to be quite instructive when you do things like threat intel. How deeply can I burrow into the infrastructure of a criminal, let's say, to learn how it is that they operate? And there's certainly operators out there who don't worry about those legal aspects, but your organization may be more risk adverse on that front. At this point, we're also thinking about incident classifications. That's going to be important later, especially for our statistical analysis, but also important for working out, well, what are the main types of incidents we're seeing today? Are we getting a lot of phishing? Are we getting a lot of malware? How much time are we spending on each of those, and how well we're responding? So not only the things we're seeing now, but what are the things we expect to see in the future? When you come to a conference like this, talking to peers, are we expecting to get a DDoS extortion attack in the near future? Okay, so that's an incident category we need to think about, and we need to start planning for it as well. Very importantly to me, maybe one of the most important things here at level 1 is that management has started to buy in to this idea that we need incident response capability. You see some technical people doing great stuff with very few resources. They have no budget. They've got a bunch of duct tape scripts, which are doing really clever things. But at the same time, there's a cap for how far they can go with their capability if they can't get new staff, if they can't get the budget to go beyond this. So there's some point where there has to be a champion, either one of those rare technical people who can do good technical work but also speak management-ese and be able to sell the idea and the importance of what they're doing further up in the organization. But that's really critical at this point if we're going to grow past level 1. And at this point also, they also have a loose understanding, maybe not documented, about their constituency, the people that they're serving and the people that they're going to be responding to. It might seem obvious for say a corporate CSERT that, well, that's everybody in the company. It's often not quite as clear-cut as that. If we have a managed service provider outside a company managing servers, say, Are we also going to do incident response for those platforms, or are they responsible for those platforms? And it's much better to talk about, well, who is responsible now, rather than when an incident is unfolding and everybody's panicking, because that is not when we're going to have rational discussions about who's to blame for these things. Continuity of operations is another thing we're going to have to look at. So we have, up until this point, our two put upon system administrators who are just mentally, they're holding a lot of this expertise in their minds. But if one of the two of them leaves, they've lost half their capability. If the other one goes on holidays, they've lost all their capability. We need a way to be able to reproduce these processes and do them reliably, no matter who is actually going to be handling the incident. So at level 1, we're still pretty immature here. We've got some documentation, ideally wiki, ideally not a Word document that we're going to stash away in a file server and forget exists for 3 years. These documents get updated so frequently, need to be reviewed so often, that they need to be in a place where everyone has access and everyone is editing continually. Something that seems really obvious, but is surprisingly lacking in lots of organizations, is a way to track incidents. So there's commercial software out there, there are open source pieces of software out there that let us tag an incident with a unique identifier, which we can use in all our communications. It also lets us log the status. Is the incident open? Is it in progress? Has it been closed? Has it been assigned to somebody? Who did we talk to? What are we waiting on? There's still a lot of organizations with really significant security budgets, and they're still using Excel to manage all of this stuff. Or they're still operating just out of an inbox, and they just call out across the room to each other to work out who's working on which incident. And as soon as you're dealing with any sort of volume of incidents, this falls apart really quickly. So level 1 is the point where we really want to introduce a system that lets us catalog and track all the things that we're working on. And it doesn't have to necessarily be incident management software. It could be your regular help desk software in a pinch. But the same stuff that is for tracking dead monitors and requests to change passwords can also be sort of co-opted into a way of tracking security incidents as well. At this point, we're also making sure that we always have a responder available. So we have to ideally have something in the way of shifts. We can't have all our responders going on holiday at the same time, and they always have a way to be able to respond to incidents. And they also have a defined procedure to work with for their incident response. At this point, it's pretty broad. It's more of an idea about, well, how do incident reports come in? Where do we log them? What do we do after that? It may not refer to specific scenarios, but that's something we're going to fix up very shortly in level 2. We're starting to have some processes as well around our incident response. So as our analysts are working on things, they're not just sort of working on things and dropping it and forgetting it. They're logging what they did in a structured way. What did we see? Which host names did I see? How did I learn about that host name? This URL, is it active? What was behind that URL? These are all things we're going to log because they're going to be critical for post-incident analysis, and also essential that when I rotate off an incident response role, somebody else can pick up where I've left off, and they know exactly where I got to my investigation and how I got to the conclusions that I had. So something we have to start enforcing at the beginning, everyone to do, so that eventually it becomes habit. We've also started to get central notifications and escalations. So I think for a lot of incident responders, it's the same, I think, as for people who go out and swap out those dead monitors. As soon as someone in your organization knows that that's what you do, they will just harass you forever. If they know your personal email, if they know your phone number, if they know where you sit, they will come straight to your desk and ask you. And this is where you have to be firm and polite and brush them aside and say, no, you have to log it through the help desk, or you have to ring our incident response team's phone number, because that is the channel we are using, and it makes sure that everything follows the correct procedure, and there's no sort of black ops incident reports, or there's no black ops investigations that are going on. This is also the point that we're starting to bring senior management into escalation itself. It's a theme I'll touch on a bit later as well, but when I'm going in personally and going and reviewing a lot of incident response teams, I make a habit of going not just interviewing the incident response team, but interviewing other managers of other sections. And the feedback that comes through very often is that incident response teams are often formed by technologists, and they have a big technology bias and a big technology focus. But there are decisions that technologists can't make. If you have a major incident and you've lost multiple systems and multiple business processes are affected, somebody who is a Linux admin shouldn't be making the decision about, well, which critical business process do we stand up first? That's the job of senior management. So this is why at level 1, they are part of our defined escalation process. They're part of our incident response process. It's not a purely technical endeavor. It requires input from people who are on the business side of the fence as well. And also at level 1, we're starting to escalate externally. We've predefined relationships with our ISP, with our external DDoS mitigation providers, with our national certs, or with sector C certs. Forming those relationships at the time of the incident, once again, we're going to have to go through a labyrinth of help desks and lower tier staff until we get to the people who are actually going to be handling our incident for us. So forging those relationships now is also really critical. Level 1 is also where we're going to start building our data capabilities. So all the technologies I touched on before, threat intelligence, machine learning, big data, hunting, having access to a wide array of data and making sure that data is well stored and cataloged. None of those 4 types of more exotic technologies can take place unless we have the foundations of the data in place. So the first thing we need is to be able to know our internal systems. What are the critical systems inside our company? Which are the ones that would collapse if those systems did not exist? At this point, that's not systematically stored. We have a vague idea in our heads that we know, well, this is where we store our customer information. If we lost our website, we would just cease to trade at that point. There's no up to the minute record of what's running inside our organization, but we know things like vague operating systems and vague patch levels. And that's going to be important because we have to start tracking vulnerabilities and exposures. So if you subscribe to an organization like AusCERT, you'll know that they push a list of vulnerabilities coming from all sorts of different vendors. So you'll see ones from Microsoft and Red Hat, ones from small research teams who have uncovered a new and emerging vulnerability. But we have to be across those vulnerabilities at this stage to know how are our systems exposed to those vulnerabilities that are up and coming. To tie into all of that, we need to start acting as a bit of a diplomatic function, because very often logs aren't in the hands of any one person within an organization. So in the case of ACO and with AusCERT, it's a 500-person organization. We have 20 people in IT. But there are going to be a range of system administrators who hold essential logs that we need, things like DNS logs, web proxy logs, email logs. And unfortunately, when we're starting to handle an incident, getting access to those logs firstly takes time, and secondly, there are some psychological elements that we have to be able to deal with. I have a good friend who's an organizational psychologist, and he tells me that the friction he often sees about collaborating, it sounds great that you're all working for the same company, so it makes sense that you're collaborating. But there's 2 elements, fear and control. The control element is that if I hold this data, that kind of solidifies my value to the organization. I'm the gatekeeper of this, and you have to come and see me if you want to do business with me. And the other one is fear. And fear is the one that plays out even more in an incident. Because if I, as the incident response team, if I don't have access to that information today, a major incident is happening and I'm coming and asking you for your logs, there's that fear that somehow I've done something wrong. So there's that sort of subliminal level of resistance to wanting to be able to hand over these. So the much better way to do this is negotiate these treaties in peacetime. Run around and shore up these deals to get easy access to data before the incident's outbreak, and then when it's happened, I've got everything I need at my fingertips, ideally being stored somewhere central, which we're also going to talk about shortly as well. So that's talking about internal data. What about external data? In the last 4 years, well, much earlier than that, there's been an explosion in the amount of data feeds out there. And I'll call these, rather than call them threat intel feeds, we can sometimes call them threat data feeds and threat information feeds, as I was alluding to before. There's no shortage of data. The main problem we have at this point is being able to consume it. The very common pattern I see is people getting really excited and going out and subscribing to 20 of these data feeds. And they get all delivered via email, and their CSV files and PDF files and all the rest of it. And they've got some really good stuff in there. And they sit in an inbox, and people open up the CSV files for about a week. And then they realize that they don't know what to do with them after that. You can't just read lists of hundreds of URLs and blacklisted domains day after day without a way to start processing that. But it's great that at least we're going out and looking at them here at level 1 of this maturity process. So we're starting to see that data, even if we don't know what we're doing with it just yet. So at this point, are we ready for threat intel, machine learning, and its cousins? We're starting to get some base elements. We're starting to get data in. We're starting to think about the internal data we're going to need access to be able to get visibility of the attacks we're going to be defending, so we can start matching up these external lists to the internal data that we've already seen. So now we move on to level 2, our second last level in this maturity model, and this is when a lot of the refinements are going to happen that are going to set us up to start using all of these new and interesting analytical techniques. So the first thing we have that's big is a team mandate. So at level 1, we had defined our team, so the incident responders knew they were incident responders. At level 2, we've got very high level buy-in. We've got support from the top level of the organization that says the incident response team has these powers. They have the ability to investigate across the company. They have the ability to co-opt and coerce other teams to be able to enlist their services, enlist their data, enlist their expertise when it comes down to an incident. Our services have started to expand as well. We might be doing 24/7 coverage because certainly incidents don't stop overnight. They don't stop on public holidays. We started to bring media strategies into this. So far we've talked about technical responses to incidents, but if we have customers, if we have partners in our company, if we're holding customer data, making up a media strategy on the fly for what do we tell our customers, what do we tell our partners, what do we write on social media as the incident is unfolding. And that's not going to be the technical team generally. It's going to be talking to the media team or talking to, in some cases, the media officer. And it's good to be able to draft those, once again, in peacetime when we're not panicking about what's happening. So we know what we're going to say and when we're going to say it. We're starting to run incident drills, another very neglected bit of forming incident response processes. So it can be great to have incident response plans, of course, but on the other hand, it's terrible if we're really finding out how effective they are at the time of the first critical incident. And incident drills can go from very simple communications checks to make sure that people are answering the phone numbers and email addresses that we thought they would be, all the way up to quite complex simulations. And that also comes down, in many cases, to budget and capability as well. We've started to really double down on our data here. Rather than just getting the access to data across the organization, we're starting to centralize it, either in a SIEM or Splunk or the ELK stack, using things like Logstash and Elasticsearch. So we can, at any point, query historical information in a normalized fashion, because of course our logs are going to be in utterly different formats. And when I type in a domain name or a host name into, say, Splunk or into Elasticsearch, I need it to search across all my logs at the same time. And that requires a fair amount of budget and resources, because we start off with our 2 system administrators with very few resources, but to do any of this stuff, we're going to start needing a lot more people, more budget for software to be able to achieve some of the techniques that we're going to need, like threat intel, like hunting, to be able to actually identify when incidents are occurring. The other big observation that gets made to me from going and interviewing incident response teams or interviewing the other business units they do business with internally, how would you say, their internal clients, is that often the incident response team doesn't understand the business processes of other sections of the business. They're focused on the technology and the technical responses, but they're not so focused on, well, they don't understand how the call center works. They don't understand the environment the call center operates in, the way that their workstations are locked down, or the type of work it is that they do. So often even sitting in for an afternoon with teams from across the organization out at the branch network, what happens at the customer coalface, that can give you a really good understanding as a technical incident responder of what are the pragmatic constraints about what we can do and what are the important things that we have to bring back online quickly if we have a critical incident. For a level 2 cert as well, particularly when we're talking about threat intel, because when we're talking about threat intel and understanding the actors behind a lot of this activity, it requires a lot of prodding and poking. So we're going and logging into clandestine websites and channels or analyzing malware. We need not off the books is the wrong word, but we need an isolated environment so that we can both handle unsafe files in a clean manner. We can't analyze malware on our corporate network, so we're going to run into trouble very quickly. And we also need a non-attributable network so that we can prod and poke things externally without drawing too much attention to ourselves, or at least not making it known who is doing the prodding and the poking. Our incident continuity once again. So in level 1, we started to have some continuity of incident response. In level 2, we improved that. We had an incident response plan. Now we're doing incident playbooks. Now there's a great book written by the Cisco CSERT, I think they call themselves a PSERT actually, and the book's called Crafting InfoSec Playbooks from Memory. And it talks about good guidelines for making very technically specific cookbooks for firstly, how would we detect this incident? What is the exact Splunk or Elasticsearch query I would run to find out what would be affected by that incident? What's the business impact of this incident? And this is really important because as we grow that team, it means that any one of our responders can just step in and start taking over the handling of that incident. And at this point as well, the team is becoming a lot more cohesive. We've got ways of the team being aware of what are the incidents we're handling, what are the backlog of incidents, who's the current on-duty handler, things that didn't exist before this point. And we also have multiple tiers of analysts. We've got our initial triage analyst that is just dealing with buckets and buckets, often of noise, of bad reports, but they're sort of isolating a lot of that stuff out. They're throwing a lot of things away. They're sending templated emails to clear those out of the way. Ideally, we've got a second stage of incident responder who can then start looking in more detail about any particular incident. We may even have a third tier who can spend a week or 2 weeks working on a single incident that requires that level of attention. Very important with our threat intel when we're doing long-term, in-depth investigations of threat actors, the tools, and the processes they use to attack us. Our automation is starting to grow as well at this point. At level 1, we had a lot of duct tape scripts. They're always out there, the Perl scripts, the Python scripts. They're unmanaged. There's one version of the script, or the way we do change management is script underscore v1, script underscore v2, and we make changes directly into our production systems. So at this point, we're starting to bring proper software development methodologies into our incident handling scripts and our data processing scripts. And we're starting to glue, so we're also buying platforms in. We're buying Seams and Elasticsearch and Splunk. And we need to demand that they all have APIs so that I can write scripts that bring data from across all of these systems and allow us to correlate. Because without that correlation, we're going to have individual facts, but we're not going to be able to piece them together. And level 2 is when we start to build out that capability as well. So automation is also not magical. There are costs and effects from doing automation. So firstly, I mentioned the need to move from this duct tape idea of doing really ad hoc, off-the-cuff scripts to doing proper software development processes. So effectively what that means is you often have a software development team inside your incident response team. And the thing I also see a lot is you end up with one of your incident responders doing so much software development work, you lose them as an incident response resource because they're now full-time doing software development. And now they are a bottleneck because they're the only person who may know how to do software development or the only person who knows how to maintain their scripts. So we also have to make sure that we adequately resource this guerrilla software team inside our incident response team. We also think of automation as solving a lot of fatigue, as a way of being able to quickly do all of this tedious manual work. And it certainly does that. But there's this interesting other idea of fatigue that it introduces, which is monitoring fatigue. So we have processes that do a lot of automation, but I have actually the same organizational psychologist friend. He works with drones, and he works with, as in aerial drones in militaries. And they use a lot of automation in flying these drones. And they find that in spite of drone operators sitting on the ground or in a container, virtually piloting drones, they get fatigued because a lot of it is hands-off. And the fatigue comes from not knowing when they can relax and not knowing when they can pay attention. And it's the same thing when we're dealing with automated scripts. We think we build a script and now it's hands off and can do its thing until we come to use that data 6 months later and we find out that it broke 6 months ago. And the assumption that we made about what was going on is not at all true. So there's a level of fatigue in that we have to monitor the things that are monitoring our logs. So we also have to think about, do we have the resources to be able to do that? Incident processes themselves and the maturity. I touched on this earlier, this neglected part of the incident response cycle, and that's post-incident review, because that's where we're going to get our lessons learned. We're going to be able to extract the indicators and sightings that we've seen and feed that back into a threat intelligence cycle. And it's often at this point when we've got bigger headcounts and more resources that we've got the ability to actually properly do post-incident analysis. Because often that's the first thing we throw away when we're just overwhelmed with incidents. We've also started to define our escalation formally through the organization all the way up to senior management and how they're going to be incorporated into responding to incidents. And we've also thought about the business continuity of our incident response team itself. I also find that incident response teams are so concerned with business continuity of the other areas and of the technology platforms that they've forgotten about the fact that what if we lost our wiki and all our documentation during an incident? What would happen if we lost the ability to call each other or email each other? Do we have a way to redundantly communicate to each other during the course of an incident? It's something that's just worth thinking about ahead of time, of course. The other thing that's increasing is our data capability. I mentioned before about dragging in all these feeds and them sitting just in an inbox doing nothing. This is the point where we start to formally ingest a lot of feeds and normalize them and put them into Splunk or Elasticsearch in many cases. There's good software out there now which does this, both in the open source worlds and in the commercial worlds, because the challenge we have, there's so many feeds, all with different delivery mechanisms, all with different formats, and they all call the same data by totally different names. So we need a way to handle all those mechanisms, reformat everything the right way, and rename everything so that when I search for an IP address, I'm talking the same language across every single one of these feeds. And this is a fair amount of work to stand up this type of capability. But once we've got this in place and it's all sitting in Splunk or Elasticsearch or the like, or a data store, now we can start doing our correlations and our enrichment. Level 2 is also the stage when we're starting to not just look internally, but we're starting to forge good communications outside our organization. So particularly for things like threat intel, there's, as well as being able to go and subscribe to commercial threat intel feeds, there's a barter economy that happens. So by knowing other incident response teams and by knowing what they're working on, we can exchange information with them. So that might also be communications with a national CSIRT, and because they're going to be publishing indicators that they're seeing from across all their constituents, or it might be those close peer communications that you have with other trusted teams. The other thing we're doing here is starting to build incident statistics, because we're at the verge of doing things like threat intelligence and machine learning, but we can't measure the success of those programs unless we have a baseline of how well we're handling incidents today. So we know things like the type of incidents, how long it's taking us to close incidents. If we don't measure those types of things, then we don't know the impact of these new and expensive, probably, programs that we're going to start bringing in. So are we ready for threat intel, machine learning, and hunting? Yeah, we're doing a lot of this now. So we don't have, these are not mature processes yet, but we have all the bedrock in place, and we're probably doing parts of what I've described earlier. We're doing that today. So the final stage is really when you're at the cutting edge of what a lot of CSIRTs are doing. So you started to procedurize to the point where I can handle a lot of security functions away from security specialists and over just to general ops staff who don't have particular security training, but there are tools, there's automation, there are written procedures for how to do a lot of things. We're starting to publish statistics about what we're doing. We've started to bring in a threat intelligence platform so that we've got tools to help us do this automation, ingest all of this information. And we're starting to look at those really, there's emerging forms of analysis, things like big data analysis, things like machine learning and novel types of analysis, more statistical analysis than they are machine learning analysis, but they're starting to develop as well. So are we ready for threat intel at this point? Absolutely we are. We're doing these programs, we've got all the essentials, we've got our incident response down and into quite a mature place, so that as we incorporate all these advanced techniques, and we've detected the things we couldn't detect before, we're now in a position where we can respond to that in a really mature fashion. So what I would urge as a summary of this talk is really, it's great to come to a conference like AusCERT and hear about all the cutting edge stuff that people are doing, but I hope that going through this maturity life cycle, you are able to identify maybe what stage of this maturity cycle you're at and maybe what gaps are there at the moment. So when you go back to your organizations working out, well, what do we need to maybe refocus on a bit more before we start to bring in all these great new techniques that we have. Thank you very much.